Hello students, today we're going to solve another problem from chapter 4 related to 2D motion. So problem number is 48. Here we have a projectile is shot at a hill, the base of which which is 300 meter away. So delta x is 300 meter. Projectile is shot at 60 degree above the horizontal with an initial speed of 75 meter per second. Now the hill can be approximated by a plane sloped at 20 degree to the horizontal. So relative to the coordinate system shown in following figure, the equation of the straight line is y is equal to tangent 20 degree multiplied x minus 109. So we have to find basically where on the hill does the projectile land. So we have to find the delta y or y where it will land on the hill. Okay, so basically it's look like this one. X is 300 meter, initial velocity theta is given. We also have z angle which is 20 degree. Now the linear equation of the straight line is given as a form of y is equal tangent 20 degree x multiplied minus x minus 109. So as you can see here, if you take this whole distance, okay, if you take this whole distance, okay, so basically if you take this whole x, let's make this one x total, which is x plus x dash. Okay, if you take this x total and if you plug it into here, then you will get your y. Okay, but however we don't know what is this x dash. Now that's what we have to find. So first of all we have to find formulas, unknown things, and then finally once you find x dash, not x dash and plus is 300, or in other words, if you can find x total, you substitute in the x and you can find what is the y. Now let's start solving this problem then. First of all, let's write down the components of x and y for the velocity. So basically we have vx initial, which will be v initial multiplied cos theta. Okay, then we have vy initial, which is v initial multiplied sine theta. Okay, then let's write down the formulas for the y component. Delta y is equal v y initial t minus gt squared over 2. Okay, so delta y is equal v initial y was equal to v initial sine theta, which means we can straight away plug the numbers. 75 multiplied sine 60 degree t minus 9.8 t squared over 2. Okay, then your delta y is equal to 75 multiplied to sine 60 will give you 65 t minus 4.9 t squared. Okay, now then what you can do, actually you can make it equal to this y. Then what you will get, so you will get tangent 20 degree multiplied to x minus 109 is equal to 65t minus 4.9 t squared. Okay, now tangent 20 degree should give you 0.36. So 0.36 times x minus 109 is equal 65t minus 4.9 t squared. Okay, now our aim, as I said, we have to find the total distance, total x. Okay, this total x. So that means we don't know the time, so somehow we have to replace time with another parameter so that we can find our x. Now, in order to find the time, let's look at the x components, okay? Our total x will be equal to Vx initial times t, okay? From here, we can say that Vx initial was equal to V initial cos theta, and if you plug the numbers, then we can get that 75 multiplied cos 60 degree multiplied to the time. So if you do multiplication, then you will find that it's equal to 37.5 t, okay? So that means the time will be equal x, the total we'll write down later on, x divided by 37.5, okay? Now finally you take this t is equal x over 37.5, and then we'll plug it into both times, okay? So if you plug them, once you plug them, I will make it short. If you plug them, you should get that it will be 0.0035 x minus 109 is equal 1.73x minus, okay guys, just one moment, I just made a mistake here. So what you have to get, actually you will get 0.36x minus 109 is equal 1.73x minus 3.48 times 10 to the power minus 3x squared, okay? Then finally, if you rearrange this one, you should get 0.0035 x squared minus 1.37x minus 109 is equal to 10. Now if you do quadratic equation, you will find that your x is equal 459 meter, this is x1. Your x2 is equal minus 67 meters. Obviously you don't need to take the negative sign, you can take only the positive. So your x is equal 459 meters. Once you found this x, then you can just substitute it into here. So your y is equal tangent 20 degree multiplied 459 minus 109. So you will get that your y is equal to 58 meters. Okay, this is how you find or how you solve such a problems.